Welcome back, everyone. In this video, we are going to start our next unit and our final unit of the semester, which is looking at quadratic relations. So we're going to be looking at a few different shapes, and the first shape is a circle, which should be a little bit easier to work with. It'll get more complicated as we go through the unit. First, we're going to start off with defining quadratic relations. So our book calls this unit Quadratic Relations and Systems. Quadratic relations all have the following form. If we look at their equation, they have an x squared, they have an xy, they have a y squared, an x, a y, and then maybe a constant. And then we can say equals 0 on the right side. So this is what the variables look like. And then we will have a few coefficients in every equation. So all of the shapes that we're going to look at, their equations will look something like this. And for the coefficients, just could be any number. We're just going to use capital letters A, B, C, D, E, and F. So A, B, C, D, and F are just coefficients. And some of the shapes might be missing some of these terms. In other words, the coefficient might be 0. So it's okay, for example, if we have just the x squared and the y squared. That's still a quadratic relation. They're called quadratic relations. So first, the quadratic comes from the fact that we have an x squared and a y squared. So we're looking at variables raised to the second power, quadratics. The relation part comes from the fact that we're looking at relations, not functions. So remember, functions have to pass the vertical line test. If we think of a circle is not a function, it's a relation because it does not pass the vertical line test. We have more than one y value for a given x value. Okay, so our unit is going to look at quadratic relations, and we're starting off with the circle. So if I asked you to define a circle, you might say, okay, the circle is just this. It just looks like that. But if I asked you to define a circle using words, it's a little bit more difficult unless you've been learning geometry recently. Circles we can define geometrically more than just drawing an example. Circles are defined as the set of points. So it's a set of points where each point is equidistant from a fixed point. And that fixed point we call the center of the circle. So a circle is a set of all points all equidistant from a set of points all equidistant from a fixed point called the center. And we can take a look at this using a coordinate plane. So if we scroll down a little bit. So here on our coordinate plane, let's just start off. Let's say our center is here, 0, 0. And if we have a circle with radius 3, then it's going to look something like this. It's really not the best circle, but you get the idea. So this is our circle, and every point on this circle, so when we talk about a circle, we're talking about all of these points, is the same distance from the center, a distance of 3, no matter what point we look at. It's going to be a distance of 3 from that center. So circles are defined as the set of all points equidistant from a fixed point called the center. When we talk about circles, we'll describe them using that center. We'll also describe them using this distance that the points are from the center, which we call the radius of a circle. So some of this is kind of a review. We should be familiar with circles, but it's important that we define circles before we explore them a little bit more deeply. All right, next we're going to look at the equations for circles. And instead of just giving you the equation, what I want to do is take a look at the circle that we drew and use that to help us find the equation. Let's say that this point is x1, y1, or we could even just do xy. So any point on the circle xy, and then let's call the point in the center h comma k. So we have our center point, and then we have the coordinates xy for a point on our circle. One way to express the radius or the distance from the point on the circle to the center is using the distance formula. So we're looking at a coordinate plane here. We can just use the distance formula. We know that the distance between 2 points squared equals the square of the differences between the x values and the y values. So it's equal to x minus h squared plus y minus k squared. So this is our distance formula between 2 points. Because we define the distance as the radius, which we can denote as r, we can write r squared equals x minus h squared plus y minus k squared. Oops, and this should be a squared outside of the parentheses like that. Okay, so the distance formula shows us how we get this right here, which is our equation for a circle. So if we're given an equation of a circle, if we didn't start off with our graph, what we could do is identify some of the key points from the equation. For example, here we know that h and k tell us the center. X and y are the different x and y values for all the points on our circle. And then r on the left here, r squared is going to be on the other side, which is our radius. So given an equation, we can identify some of the key points. And we found this equation using the distance formula. Next, I want to go through an example of identifying these features given an equation of a circle with some numbers. Okay, so here we are being asked to graph this equation, x minus 2 squared plus y minus 3 squared equals 4. And we can use our equation that we just saw to identify the key features of our graph and then easily plot the graph. For example, here x minus 2 tells us that the x value for the center is going to be positive 2, because if we look back, we're looking at subtracting. So one thing to be careful of is it's x minus h, y minus k. So 2 is our x value. And the subtraction is important because over here we have y plus 3, which if we think of subtracting is the same as y minus negative 3. So negative 3 is our y value for our center. So right away we identified the center, 2 comma negative 3. And then we know the radius can be found on the right side. We know that r squared is equal to the value on that right side, 4. So in this case, we take the square root of both sides. We get r is equal to 2. Normally when we take square roots, we'll look at the positive and the negative, but the radius or distance has to be positive. So we'll just be working with positive 2 in this case. All right, so we have the center and the radius. So to plot our graph of a circle, what we could do is first plot the center, 2 comma negative 3. And then we know we have a radius of 2. So what I do is I always just plot the points on in the y direction and the x direction, and then we can just kind of fill in the middle in between them. Nice, so a little bit nicer than our other circle. So here we have our graph of this equation here. So with circles, especially if our equation looks like this, we can pretty easily identify the center and the radius and then graph our circle quickly. All right, finally with circles, the last thing we're going to talk about in this video is how circles are related to cones. So our title for our unit is quadratic relations, but another title that you'll see sometimes and one that I'll use often is conic sections. Conic sections are sections or cross sections of a cone. So conic cone and then a section from that cone. So all of the shapes that we're learning in this unit can be found by starting with a cone and then cutting out pieces from the cone and looking at the cross section, the part that we cut out. For example, starting off here, we start with a cone in number 1. So over here, start with a cone, and then For number 2, what we're doing is we're cutting out a section of that cone. And I have kind of like a flat piece of paper there to represent what we're cutting. And I also have a side view to show you that the paper that we're cutting is actually parallel to the bottom of the cone. So this section we're cutting out is exactly horizontal if we had the cone like placed on a table. So we're cutting into this cone. And as you can see in step 3, all I did was show that we can, after we cut it, we can kind of like take these pieces apart. And we're looking at the cross section, so the colored in parts of our cone here and here. And this cross section is the shape that we're studying. So our first shape is circles when we cut parallel to the bottom or at a horizontal. The cross section that we end up with is a circle. So circles can be described using cones just by cutting a cone horizontally. We'll see as we learn other shapes, other quadratic relations or conic sections, we'll see how we can find other shapes by cutting the cone in different directions too. Finally, with circles, our last point that we're going to learn about is looking at the equation of a quadratic relation, and from that equation, identifying whether we have a circle or not. If we have a quadratic relation like this, or an equation like this, so previously our equations were x minus something squared, y minus something squared. If you were to expand all of it into the x squared, xy, and so on, all of these terms, we can identify that the equation represents a circle if a is equal to c. In other words, if the coefficients of x squared and y squared are equal. So for example, if we had 2x squared plus 2y squared equals, minus 4 equals 0, something like this, here we do in fact end up with a circle because we have the same coefficient in front of x squared and y squared.